The screen is visible to all the students. PPTs. PPTs are visible
No, sir. Participant list is visible.
right now. PPTs.
No, sir. Participant no, sir.
One second, I will share. Right now, PPTs are visible.
Yes, we can see.
Okay, then we'll start. I think in the last lecture on Thursday, we reached up to the fourth type of parallel clipper. In the last lecture, we have started the first type of parallel clipper, that is positive clipper and a negative clipper unbiasing. I have told there are four types of parallel clipper also, same as series clipper. First type is positive unbiased clipper, second type is negative unbiased clipper, third type is positive biased clipper, and fourth type is negative unbiased clipper. Okay, so I think we reached up to the last type, that is parallel negative clipper circuit with biasing. Okay, so we will see this type first, and then we will start the next application of PN junction diode, that is clamper. Same as third type, that is parallel positive clipper circuit with biasing. Here also we have to see the operation of parallel negative clipper circuit with biasing. Here also that circuit consists of one current controlling resistor, that is R. It is connected in series with PN junction diode D. Also we have connected external biasing voltage or the external potential VB in series with PN junction diode D. Okay, and here at the output terminals we have to measure the output voltage, and we can connect the load resistor RL also at the across the output terminals, and across the RL we are measuring the output voltage V out. Okay, so at the input side we are applying the sinusoidal signal, that is sine signal as the input signal. With the help of that sine signal we are going to see the operation of that last type, that is parallel negative clipper circuit with the biasing. Okay, so here the direction of PN junction diode has been reversed according to the positive parallel clipper. याची डायरेक्शन चेंज केलेली आहे, त्यानुसार आपल्याला काय बघायचं त्याचं बायसिंग क्लिपरचं ऑपरेशन बघायचं. So we will see one by one. First of all, we will see first half cycle. For the next, we will see the next half cycle. So the first half cycle here in the input signal, that is positive cycle. Suppose it will be varies from 0 to pi. That positive cycle is connected to the input terminals. Means by applying the positive cycle, the polarity of the input terminals will be positive at the upper side, negative at the lower side. So by connecting this positive cycle, if you see the circuit diagram, the positive terminal is connected to the cathode of PN junction diode D, and here negative terminal is connected to the external potential VB. Means first of all we have to find out here the resultant potential from the input voltage V in and the external potential VB, and already I have told how to find out the resultant potential if we are having the two potentials. So right now in this circuit we are having the two potentials. First potential is the V in, second potential is the VB, and here if you see the positive of the V in is upper side, negative of the V in is the lower side. Means negative terminal of V in is connected to the positive terminal of VB, and a positive terminal of V in is connected to the negative terminal of VB. Means from this connection we can say that the two potential V in and VB are in series connection, because opposite terminals are connected to each other. If the same terminals are connected to each other, means these two potentials are in parallel connection. But here opposite terminals of two potentials are connected to each other. That's why these two potentials V in and VB are in series connections. And as we know that if the two potential are in series connection, that time the resultant potential will be addition of both the potentials. And so here if you consider the resultant potential is V, so V is equal to V in plus VB, and the polarity of the resultant potential will be same as the that potential or this potential. So according to this, for the complete positive half cycle, that is from 0 to pi, the positive terminal will be upper side, negative terminal will be lower side. Means for the complete half cycle or the complete positive half cycle, PN junction diode D, the positive terminal is connected to the cathode of PN junction diode D, negative terminal is connected to the anode of PN junction diode D, means PN junction diode D is in reverse bias, and when the PN junction diode D is in reverse bias, for the ideal condition it is act as open circuit, means when it is act as open circuit, that time there is no current flowing from the first loop, म्हणजे R D आणि VB जे आहे त्या लूप मधून काय होणार नाही, करंट फ्लो होणार नाही, कारण तुमचा PN junction diode D ओपन राहणार फॉर द फर्स्ट पॉझिटिव्ह सायकल, मीन्स current will be flow from the second loop, that is R, and here across the Vout we are connecting the RL, so R, RL, and then negative terminal of input voltage. So the current will be flows through the second loop, and when the current will be flows through the load resistor RL, it will generate the output voltage Vout, and here we have to calculate the output voltage Vout with the help of voltage divider rule, and I have told here to find out the voltage drop across the load resistor RL. By applying the voltage divider rule, V out is equal to the input voltage, and here input voltage is the V in into load resistor RL divided by RL plus series resistance R. So what is the final equation for the V out? V out is equal to, suppose we are considering the load resistor RL, so V out is equal to input voltage V in into RL is the load resistance divided by RL plus R. But for the ideal condition we are considering that the current controlling resistor R is the very negligible, or its value is very less, and we are neglecting this value for the ideal condition. So by neglecting this value, the final equation for the V out is equal to V in, because V out is equal to V in into RL divided by RL. So RL get cancelled. So the final equation for the V out is equal to V in, means from this equation we can say that for the first half cycle, that is for positive half cycle, the output voltage will be same as input voltage. That's why in the output waveform, the waveform is drawn same as input waveform for the first half cycle, that is for positive half cycle, that is from 0 to pi. म्हणजे 0 to pi मधली जर वेवफॉर्म इनपुट आणि आउटपुट वेवफॉर्म जर तुम्ही ऑब्झर्व केली तर दोन्ही वेवफॉर्म काय आहेत, सेम आहेत फॉर द आयडियल कंडिशन, बिकॉज VO is equal to, or VO out is equal to V in. Okay, this is for ideal condition. If you consider the practical condition, the output is slightly less than the input voltage. Okay, this is the operation for first half cycle. Then we will go for the operation for the negative half cycle. Here for the negative half cycle we are applying the half cycle from the pi to 2 pi. For the negative half cycle, the polarity will be negative positive, means negative at the upper side, positive at the lower side at the input terminals. Means if you observe the two potentials V in and VB at the negative half cycle, for these input terminals V in and VB are in parallel connection, because positive of V in is connected to the positive of VB, negative of V in is connected to the negative of VB, means V in and VB are in parallel connection, and when V in and VB are in parallel connection, that time its resultant potential is higher potential minus lower potential. Okay, and here by considering two conditions we have to see the operation for the negative half cycle. There are two conditions. Okay, so first condition we will consider that the input voltage V in is less than external potential VB. Suppose we will consider the value of VB is equal to 3 volt and value of V in is equal to 2 volt. म्हणजे काय झालं, V in हा तुमचा जो potential आहे हा VB पेक्षा कमी आहे. For this condition what will happen we will see. So V in is less than VB. For this condition we have considered the value V in is equal to 2 volt, VB is equal to 3 volt, and for this condition the resultant potential will be VB minus V in, because V is equal to VB is higher, V in is less, that's why resultant potential V is equal to VB, that is 3, minus V in, that is 2, so 1 volt. So 1 volt is the resultant potential, and the polarity of resultant potential will be same as VB, because VB is higher potential, and we have told that when the two potential are in parallel, that time its resultant potential will be subtraction, that is higher potential minus lower potential, and the polarity will be same as higher potential. That's why the polarity of resultant potential will be same as VB. Same as VB means negative terminal of resultant potential is connected to the anode of PN junction diode D, positive terminal of that resultant potential is connected to the cathode of PN junction diode D, means PN junction diode D is in reverse bias for first condition of negative half cycle. Means for first condition of negative half cycle, PN junction diode D is in reverse bias. So when the PN junction diode D is in reverse bias, that time the output voltage across the output terminals or across the load resistor RL will be calculated with the help of voltage divider rule, that is VO is equal to VI. So up to the VB line, if you observe the second waveform or the second half waveform in the output second half part in the output waveform, then up to the VB part or up to the when Vin is less than VB, that time up to this part the output voltage will be same as input voltage. Okay, for the first condition. Then we will observe the second condition. Second condition क्या है? If the input voltage Vin is greater than external biasing voltage VB, म्हणजे VB पेक्षा जर Vin मोठा असेल, ती condition consider करूया. So we will consider the value of Vin is equal to 4 volt, because we have taken the value of VB is equal to 3 volt. So the second condition is that Vin is equal to 4 volt, VB is equal to 3 volt. So for this condition, the resultant potential V is equal to Vin minus VB is equal to 4 minus 3 is equal to 1 volt. But here the value magnitude is same, but the polarity has been changed, because the polarity for the second condition will be same as Vin, because here in the second condition Vin is the higher potential. So for the second condition here polarity for the negative half cycle ची polarity काय असणार, Vin म्हणजे negative positive. So for the second condition negative is connected to the cathode of PN junction diode D, positive is connected to the anode of PN junction diode D. So for the second condition of negative half cycle, PN junction diode D is in forward bias, it is act as a short circuit, means here for the second condition the voltage drop across the diode will be 0 for the ideal condition. And if you observe or if you measure the voltage drop across the 2 points at the upper point and lower point of the series connection of PN junction diode D and external biasing voltage VB, then it will be VB only. जर आपण जो PN junction diode D चा जो कॅथोड पॉइंट आहे, कॅथोड टर्मिनलचा जो पॉइंट आहे तो पॉइंट आणि VB चा जो खालचा पॉइंट आहे पॉझिटिव्ह पॉइंट, म्हणजे ह्या दोन्हीचं सेरीज कनेक्शन आहे. ह्या सेरीज कनेक्शनच्या अक्रॉस जर व्होल्टेज मेजर केलं तर आयडियल कंडिशनला डीच्या अक्रॉसचा जो ड्रॉप आहे तो 0 असणार. सो द टोटल व्होल्टेज ड्रॉप अक्रॉस दीज 2 पॉइंट विल बी VB. That's why the output voltage Vout will be VB, because output voltage is parallel to these 2 points. So the Vout is equal to VB for the second condition of negative half cycle. That's why it is shown by the straight line. म्हणजे तुम्हाला VB ची जी लाईन आहे ती VB ची ते व्होल्टेज यांनी दाखवलेलं आहे, आणि VB च्या वरचा जो पार्ट आहे तो काय झाला, क्लिप्ड ऑफ झाला. म्हणजे in negative half cycle the portion of negative half cycle which is greater than VB will be clipped off or will be removed in the negative half cycle with the help of biasing parallel clipper. So this is the operation for parallel negative clipper circuit with biasing. Okay, I hope all of you understood the type of clipping or the clipper circuits. In that clipper we have seen basically first 2 types. First type is the series clipper, second type is the parallel clipper. Series clipper means in series clipper PN junction diode D is connected in series with the resistor, and in second type the PN junction diode D is connected in parallel with the load resistor RL. Okay, and according to that we have seen the 4 types of series clipper and 4 types of parallel clipper. 4 types means first positive clipper, negative clipper unbiasing, second positive clipper, negative clipper biasing in the series clipper. In parallel clipper also we have seen first type positive clipper, negative clipper unbiasing, and second is the positive clipper, negative clipper, that is biasing. And simply we have understood the basic difference between biasing and unbiasing. Biasing means what? If we want to remove any particular portion of positive cycle or a negative cycle, then we will go for the biasing, and in biasing we have to add external potential voltage in the circuit, and in unbiasing we can remove or we can clip off complete positive cycle or complete negative cycle in the output waveform, and we don't require any external potential voltage for the unbiasing clipper circuit. Okay, so this is about the clipper circuit. Okay, so after the clipper circuit we will go for the third application of PN junction diode, that is clamper. Okay, so for this, see the slide number 7. First of all, we will see what is meant by clamper. I think we have seen the definition of clamper at the time of clipper circuit. So once again, we will see what is meant by clamper circuit, that is definition of clamper. So here clamper, or we can say that clamper is a DC restorer. It will be shift the waveform to the desired DC level without changing the shape of applied signal. If you observe the output waveform of clamper and output waveform of clipper, then in clipper circuit the output waveform shape has been changed, but in clamper circuit the shape of output waveform cannot be changed. That's why in definition it is told that the clamper is the circuit which shift the waveform to desired DC level without changing the shape of input signal or the shape of applied signal. This circuit is known as clamper circuit. And again here we are going to see the types of clamper circuit. So in this slide number 7, they have given the types of clamper circuit, that is positive clamper, negative clamper, and clamper with biasing. Okay, so in the slide number 8, first of all we will see the definition of positive clamper circuit, then definition of negative clamper circuit, and then with the help of circuit we will go for the first, that is positive clamper circuit. Okay, so according to clamper circuit definition, in positive clamper circuit, the if you apply the input signal, that is sinusoidal input signal, as a input signal to the clamper circuit, then in the output waveform the input signal is shifted to in upward direction, and negative clamper, in negative clamper the input signal is shifted to the lower direction, in the downward direction. Okay, so first of all, before going to start the clamper circuit, we have to see the some basic concept in the clamper circuit. So the clamper circuit is the circuit which adds a DC component to the signal and push the signal in upward direction, so that negative peak value follows on zero level and positive peak value follows on twice wave level. If you consider, or if you see the slide number 8, in slide number 8 we have applied some input signal, that is sine wave signal. Here they have considered the 2 complete cycle in the input signal, and that input signal is applied to the clamper circuit, and with the help of that input signal they have shown the output waveform. That output waveform is shifted to the upward direction. So first of all, suppose I will consider here the for the input signal its positive peak value and negative peak value. Suppose I will consider the positive peak value of the input signal is plus 5 volt. Negative peak value of the input signal is minus 5 volt. So what is the peak to peak value of input signal? The peak to peak value of input signal will be 10 volt. Okay, peak to peak value means from top to bottom. I have told here the positive peak value of the input signal will be plus 5 volt, negative peak value of the input signal will be minus 5 volt. म्हणजे पॉझिटिव्ह प्लस 5 आहे, नेगेटिव्ह मायनस 5 आहे, आणि दोघांच्या मधलं डिस्टन्स म्हणजे फ्रॉम टॉप टू बॉटम म्हणजे काय झाली, पीक टू पीक व्हॅल्यू. सो द पीक टू पीक व्हॅल्यू ऑफ इनपुट सिग्नल विल बी 10 volt. So input voltage peak to peak value will be 10 volt. Positive peak value we know, negative peak value we know, then average value we will find. Average value means average value is equal to upper peak value plus lower peak value divided by 2, and here we know that upper peak value means positive peak value, so positive peak value is plus 5, lower peak value is minus 5, so 5 minus 5 divided by 2, so average value is equal to 5 minus 5, that is 0 divided by 2 means 0 volt is the average value for the input signal. Okay, so here we have find out the 3 values for the input signal. So if you observe the output waveform in the slide number 8, then the input signal is shifted in the upward direction. By observing this output waveform of the positive clamper circuit, here the positive peak value of the output waveform is shifted to twice Vm. म्हणजे आपण काय केलं, कन्सिडर पॉझिटिव्ह पीक व्हॅल्यू इज द प्लस 5 volt, म्हणजेच प्लस 5 म्हणजेच त्याला आपण Vm म्हटलं तर आउटपुट वेव्हफॉर्म मध्ये ती काय झाली, ट्वाइस Vm ला अपवर्ड डायरेक्शनला मूव्ह झाली आहे. म्हणजे काय असणार आहे, पॉझिटिव्ह पीक व्हॅल्यू ऑफ द आउटपुट वेव्हफॉर्म विल बी 10 volt and the negative peak value of the output waveform will be 0 volt. Means Positive peak value in the output waveform will be 10 volt, negative peak value in the output waveform will be 0 volt, but peak to peak value of the output waveform is also 10 volt. कारण टॉप टू बॉटम किती आहे त्याची हायेस्ट पीक व्हॅल्यू किती आहे 10 आहे, लोएस्ट किती आहे 0 आहे, दोघांच्या मधलं डिस्टन्स किती झालं 10 व्होल्ट. सो द पीक टू पीक व्हॅल्यू ऑफ द आउटपुट वेवफॉर्म will be 10 volt, positive peak value is 10 volt, negative peak value is 0 volt, and if you calculate the average value of output waveform of clamper circuit, then here to find out the average value, so average value is equal to upper peak value plus lower peak value divided by 2. So upper peak value is 10, lower peak value is 0, so divided by 2. So 10 plus 0, that is 10 divided by 2 means 5. So 5 volt is the average value. So in the output waveform, the middle line is the 5 volt line if you consider. So by considering input signal and output signal in the positive clamper circuit, if you find these three basic concept, that is peak to peak value, then peak value, and then average value, then peak to peak value will be remain same in the clamper circuit for the input signal and the output signal. Here we have observed that if we have calculated the peak to peak value in the input signal, we have calculated the peak to peak value in the output signal also. The peak to peak value will be remain same, that is 10 volt only by considering the example. But peak value and average value has been changed in the clamper circuit in the input signal and the output signal. Here we have observed that in the input signal, peak value, that is positive peak value, is 5 volt plus 5 volt, negative peak value is minus 5 volt. In the output waveform, positive peak value is the 10 volt, negative peak value is the 0 volt, and the average value in the input signal is the 0 volt, and the average value in the output waveform will be 5 volt. So by this consideration, we can say that the peak to peak value will be remain same, and peak value and average value has been changed in the clamper circuit. These three most important points we have to consider in the clamper circuit. And the another most important point is that the shape of the input waveform cannot be changed in the clamper circuit. Just it moves in the upward direction or it moves in the downward direction to the desired DC level. This circuit is known as clamper circuit. Okay, I think all of understood what is the basic concept of clamper circuit. In the slide number 9, they have given the second type, that is negative clamper. By applying the same input signal, if you apply the same input signal of 2 complete cycle, then with the help of negative clamper, the input signal is shifted to the downward direction. Is downward direction means, if you consider again, the positive peak value of the input signal is the plus 5 volt, negative value is the minus 5 volt, and here from this we can say that peak to peak value is 10 volt, then average value is 0 volt. So in the output waveform of negative clamper, the here higher peak value will be minus twice Vm, म्हणजे minus 10 volt, and lower peak value will be 0 volt, and here average value will be minus 5 volt, and peak to peak value will be 10 volt. Okay, means here again peak to peak value will be remain same, but peak value, lower peak value is 0 volt, higher peak value will be minus 10 volt, and average value will be minus 5 volt. Means here त्याची average value and peak value काय होते change होते in the output waveform. Okay, then we will go for the first type of the clamper circuit, that is positive clamper circuit with the help of circuit diagram. Okay, here we have seen only basic concept of clamper circuit, that is definition of clamper circuit according to two types, that is positive clamper and negative clamper. Then see the slide number 10 for the operation of positive clamper circuit. Okay, so here before going to start the operation of positive clamper circuit, we will see what are the components present in the clamper circuit. So here they have connected the input voltage Vin, then one capacitor C, then one PN junction diode D, and load resistor RL. Okay, so before going to see the operation of clamper circuit, we have to see the principle of clamper circuit, and according to that principle of clamper circuit, we will see the operation of positive clamper and negative clamper circuit. In clamper circuit, capacitor C is connected in series with the PN junction diode D. The operation of clamper circuit is based on the principle of charging time of capacitor is less than discharging time of capacitor. This is the principle of clamper circuit. Means we are using one capacitor in the clamper circuit, that is C, and the operation of this clamper circuit is based on the principle. That principle is that the charging time of capacitor is less than discharging time of capacitor. Means the discharging time of capacitor C should be greater than charging time of capacitor. The discharging time त्याच्या charging time पेक्षा खूप जास्त पाहिजे. This is the principle, and that based on that principle we have to see the operation of the clamper circuit. Okay, so first of all we will see what is mean by charging time of capacitor, what is mean by discharging time of that particular capacitor C used in the clamper circuit. So for all practical purposes, the capacitor is fully charges and discharges in 5 times of charging time constant and 5 times of discharging time constant. And according to electrical constant, charging time constant for the capacitor is denoted by the tau notation. I think everybody has known the tau notation, and it is given by tau is equal to C, that is capacitance, into RF. If you consider the forward resistance of PN junction diode D, that is RF. RF is the notation for the forward resistance of PN junction diode D. So the charging time constant for the capacitor is given by tau is equal to C, that is C is capacitance, into RF is the forward resistance of PN junction diode D. So according to that practical purpose, total charging time of capacitor C will be given by 5 into C into RF. So we can say that tau C is the notation for charging, total charging time. So total charging time is equal to 5C into RF. In same way, discharging time constant is given by tau is equal to C into RL. RL is the load resistance. So according to practical purpose, the total discharging time, that is tau D, is equal to 5C into RL. म्हणजे total discharging time equation काय झालं, tau D is equal to 5C, C is capacitance into RL, and total charging time equation काय झालं, tau C is equal to 5C into RF. Okay, so in the clamper circuit, value of capacitor C and load resistor RL are selected in a such a way that discharging time, that is tau D, should be greater than charging time of capacitor, that is tau C. म्हणजे कॅपॅसिटर सी जो आपण यूज केलेला आहे त्याचं जे चार्जिंग टाइम आहे, फॉर एक्झाम्पल आपण त्याचं इक्वेशन बघितलं, त्याचं चार्जिंग टाइम काय असणार टाउ सी, त्याचा डिस्चार्जिंग टाइम काय असणार टाउ डी. तर टाउ डी शुड बी ग्रेटर दॅन टाउ सी. इफ द टाउ डी इज नॉट ग्रेटर दॅन टाउ सी, then that circuit cannot be work as a clamper circuit. This is the basic condition. त्यांनी जे प्रिन्सिपल सांगितले, that if that clamper circuit satisfy the principle of clamper circuit, then and then only that circuit will be used as a clamper circuit. Otherwise, if it is not satisfy the principle of that clamper, then it cannot be used as a clamper circuit. Okay, so based on that we will see the operation, that is first type of clamper circuit, that is positive clamper circuit. So here with the help of this circuit diagram we will go for the positive clamper circuit. For the operation we will consider negative of cycle first, that is from 0 to pi. It is easier here in this slide number 10 they have given first of all that is positive cycle, but for the easy purpose we will consider the negative of cycle first. It will be easy to understood. So by considering negative of cycle first means we are applying the negative at 0 to pi and positive at pi to 2 pi. Okay, so by considering negative of cycle at first, that is from 0 to pi, the across the input terminals polarity will be negative positive. So by applying this negative of cycle, the positive terminal is connected to the anode of PN junction diode D. Negative terminal of that input terminal should be connected to the cathode of PN junction diode D. Means that PN junction diode D is in forward bias. And by considering initial condition, when PN junction diode D is in forward bias, current will be flows in the first loop, and when the time current is flows in the first loop, that time the capacitor C will be charges to Vm level. Suppose if you consider the input voltage Vm and V in and its peak value is Vm, then that time the capacitor C will be charges to peak value of input voltage. म्हणजे इनपुट व्होल्टेजची जी पीक व्हॅल्यू असणार आहे त्या व्हॅल्यूला तो काय होणार, त्या व्हॅल्यूला तो कॅपॅसिटर चार्ज होणार. मीन्स फॉर द फर्स्ट हाफ सायकल द कॅपॅसिटर C and its across voltage will be Vm with polarity negative at the left side, positive at the right side. ओके, म्हणजे पहिल्या हाफ सायकलला तो कॅपॅसिटर चार्ज होणार, जेवढं त्याला इनपुट भेटलंय, म्हणजे त्याला इनपुट जेवढं भेटलंय व्ही ची आपण पीक व्हॅल्यू काय म्हटली, Vm म्हटलंय, म्हणजे त्या इनपुट व्होल्टेजच्या पीक व्हॅल्यूला तो चार्ज होणार. ओके, so the voltage drop across the capacitor Vc is equal to Vm with polarity negative at left side, positive at the right side. Then we will consider the next half cycle. For the next half cycle, the polarity will be opposite, the positive at the upper side, negative at the lower side. When the positive at the upper side, negative at the lower side, that time this PN junction diode D is in reverse bias. Reverse bias means it is act as open circuit for the ideal condition, means current cannot be flow through the first loop, the current will be flow through the second loop, that is from C, then RL and VA. Okay, so we have to find out the output voltage across the load resistor RL. So by applying KVL to the second loop, we have to find out the voltage drop across the load resistor RL. If you apply the KVL across the this loop, then KVL apply केल्यानंतर काय येणार आहे, पहिल्यांदा voltage drop across the C, voltage drop across the C काय असणार आहे, मायनस लेफ्ट साईडला होतं, पॉझिटिव्ह राईट साईडला होतं, म्हणजे काय असणार आहे, आणि ती व्होल्टेज ड्रॉप किती होता, Vm होता, सो मायनस Vm. देन voltage drop across the RL, you will consider the output voltage, that is VO. So voltage drop across the RL will be VO, so minus Vm plus VO, आणि voltage drop across the input voltage, that is Vn, and Vn ची पीक व्हॅल्यू किती होती, Vm होती. So we will go from negative to positive म्हणजे minus Vm. So इक्वेशन काय असणार आहे, minus Vm plus VO minus Vm is equal to 0. So minus Vm minus twice Vm plus VO is equal to 0. So VO is equal to twice Vm is the output voltage. म्हणजे काय झालं, for the next half cycle it will shifted to twice Vm. ओके, जर आपण दुसरी निगेटिव्ह सायकल कन्सिडर केली असेल तर तो काय होणार, ट्वाइस Vm ला शिफ्ट होणार आहे, आणि जी पॉझिटिव्ह सायकल आहे त्याला त्यावेळेस आउटपुट व्होल्टेज काय असणार आहे, 0 व्होल्ट असणार आहे. So for first half cycle, the output voltage will be 0. For the next half cycle, output voltage will be twice Vm. Means if you observe the input waveform and output waveform, it will shifted to the upward direction